How we doing? Um, Last week or last couple weeks we worked on integration by partial fractions, and you might have heard me goof up and say integration by parts often. They're two different techniques. They target two different big ideas. Partial fractions were all about rational functions, which was that division thing with polynomial divided by polynomial. This integration by parts actually undoes multiplication. So I'm going to do a quick proof of integration by parts in this video. In the next video or two, I will have a couple quick examples of it. So anyway, we're going to start with the product UV. And I know U's and V's, they look alike, but this is what the traditional mathematics used for whatever reason. And we are going to take this derivative with respect to x. And if we do that, we need to remember that u and v are both functions of x. And to do so, to take this derivative, we need to take the derivative by product rule. I apologize for the pause there. We need to use product rule. So we're going to say the derivative of u times v is du. Let's do it this way. U prime v plus v prime u. And we should remember that. And if we wanted to do it longhand, instead of u prime, we could just say du dx v plus dv dx u. This is synonymous. And you'll notice we have a bunch of dx's. So, I hate using the word multiply. It feels like multiplication. It's not quite right, but we can get rid of them all. Okay, we can rearrange a little bit. And what we are going to do is we are going, because everything's divisible by dx, we can just get rid of the dx's. What we're going to do is integrate everything. And when we integrate things that are being added, we can just break it apart and do the two separate things. So the integral of the derivative of uv, well, that should just get us back to uv, and it does. This is written badly. We just took the integral in the middle of it. But so this is just the integral of v with respect to u, plus this is the integral of u with respect to v, the integral of u dv. That's a v, not a u, v. Try to make the v sharp. Okay, so now what we can do is we could solve this equation for this. And so I'm going to rewrite that over here, and I'm going to move this over here with subtraction. And so what we can say is that the integral of u dv is the same as uv minus the integral of v du. And so what this means is that we can take an integral expression that we're looking for in terms of u and v, and we could integrate one of them and take the derivative of the other one and rewrite it in this form, which on the surface doesn't look like it would be all that helpful, but it is amazing how helpful this is going to be. Pardon that little light there. That's kind of fancy, isn't it? I like that. Right next to the microscope or telescope. So, yeah. So I'm gonna rewrite this at the top, and then we are going to do a practice problem after this, and show how this works. So this formula will be right up here. Anyway, we'll see you in a bit.